Welcome to the Certified Sustainable Packaging Specialist course, presented by CDG Training. Embark on a journey to transform packaging practices for a sustainable future. Let's dive into Chapter 1, where we explore the fundamentals of sustainable packaging and the circular economy, setting the stage for impactful learning. Welcome to this transformative learning journey with CDG Training. Here, you'll explore core concepts, apply them in real-world scenarios, and earn a certification recognized by the industry. Sustainable packaging minimizes environmental impact throughout its life cycle. It focuses on reducing waste, maintaining product integrity, and using eco-friendly materials. Packaging waste is a major environmental challenge, with millions of tons affecting our planet. Urgent action is needed from all sectors to address this growing issue. The circular economy emphasizes reducing waste through reuse, recycling, and regeneration, maximizing resource value and minimizing environmental harm. Transitioning from a linear to a circular economy is crucial for sustainable packaging, focusing on resource recovery and reducing environmental impact. Packaging significantly influences waste generation, resource consumption, and carbon emissions, highlighting its critical role in sustainability efforts. Traditional packaging contributes to pollution, landfill waste, and greenhouse gas emissions. Understanding these impacts is vital for initiating meaningful change. Sustainable packaging is guided by principles like reduction, reuse, recyclability, and renewable materials, forming a framework for responsible design and production. Choosing sustainable materials is crucial in packaging design, directly affecting environmental impact and determining a package's sustainability across its life cycle. Managing packaging waste is a global challenge, with issues like collection gaps and market demand for recycled materials needing strategic solutions. Consumers increasingly prefer sustainable packaging, influencing market trends and encouraging brands to adopt eco-friendly practices. Sustainable packaging offers business value by enhancing brand reputation, ensuring regulatory compliance, reducing costs, and expanding market access. New technologies are revolutionizing packaging materials and designs, unlocking innovative solutions that were unimaginable just a decade ago. Stricter packaging and waste management regulations are being introduced globally, emphasizing compliance for market access and business continuity. Transitioning to sustainable packaging involves overcoming challenges like costs and infrastructure limitations, requiring strategic management. Circular packaging systems offer opportunities for innovation, cost reduction, and resource efficiency, with early adopters gaining significant advantages. A real-world case study shows the transition from plastic to paper-based packaging, highlighting measurable improvements in environmental and business outcomes. Sustainable packaging and circular economy principles are essential for reducing environmental impact and building resilient businesses for the future. CDG Training believes sustainable packaging is both a moral imperative and a strategic opportunity, offering tools and frameworks to drive meaningful transformation. Chapter 2 delves into the pressing global packaging waste crisis, examining its environmental impact and the urgent need for sustainable solutions. In this chapter, we explore the growing global packaging waste crisis and its environmental consequences. Understanding these challenges is essential for developing sustainable packaging solutions. Packaging waste has surged due to consumerism and e-commerce growth, placing enormous pressure on waste management systems worldwide. Without intervention, this trend will accelerate. Packaging waste originates from retail, food service, logistics, and industrial sectors. Each sector contributes uniquely to the overall waste burden, requiring tailored strategies for reduction. Plastic packaging is a major contributor to environmental pollution. Its durability makes it a long-term liability, persisting in ecosystems for centuries and posing significant challenges. Single-use packaging generates massive waste and resource consumption. Though convenient, these materials are used briefly but persist in the environment for decades, creating a profound impact. Large quantities of packaging waste end up in landfills worldwide. As urban populations grow, landfill capacity is being exhausted, creating long-term environmental liabilities. Packaging waste significantly contributes to ocean pollution and marine ecosystem damage. It endangers marine biodiversity and disrupts the food chain, affecting coastal economies. Plastic packaging breaks down into microplastics, impacting ecosystems and health. These tiny particles enter the bodies of animals and humans, highlighting the health implications of packaging pollution. Packaging production consumes energy and generates greenhouse gas emissions. Transitioning to recycled and bio-based materials is crucial for reducing packaging's climate impact. Traditional packaging relies heavily on finite natural resources, placing enormous strain on the planet's natural capital and accelerating depletion at unsustainable rates. Recycling systems face contamination, sorting, and infrastructure limitations. Developing public awareness and investment is crucial for improving recycling processes and reducing packaging waste. Online shopping has increased demand for packaging materials significantly. The shift to e-commerce has fundamentally changed packaging requirements, adding layers of waste. Many countries lack efficient systems for managing packaging waste. Bridging the waste management capability gap between regions is a critical global sustainability challenge. Packaging waste incurs substantial economic costs, including marine damage and remediation. Addressing these costs is essential for sustainable economic growth. Communities face health, sanitation, and environmental quality issues from packaging waste. The social dimensions of packaging waste are often overlooked but are crucial for equitable solutions. Governments and organizations are promoting recycling, bans, and circular systems. International policy action is reshaping the packaging landscape, driving systemic change. A retailer reduced packaging waste by introducing reusable and recyclable packaging schemes. This example demonstrates that meaningful waste reduction is achievable through strategic changes. Packaging waste is a major global environmental challenge requiring urgent sustainable solutions. Circular design and material innovation offer pathways to reduce packaging's environmental impact. CDG training helps organizations address packaging waste challenges through sustainable design and circular strategies. These efforts can reduce environmental impact and enhance brand reputation. Dive into an in-depth exploration of sustainable packaging materials and innovations that are transforming the industry for a more sustainable future. Explore the full spectrum of sustainable packaging materials, understand their importance, and see how they fit into the global industry context. Discover the environmental impact and business drivers that make sustainable materials essential for reducing packaging waste and carbon footprint. Learn about the various categories of sustainable packaging materials and how they provide eco-friendly alternatives to traditional options. Paper-based packaging is renewable and widely used, offering advantages like recyclability and biodegradability, with lifecycle considerations for sustainability. Bioplastics offer a renewable alternative to traditional plastics, with innovations in materials like PLA and PHA driving sustainable packaging forward. Compostable packaging breaks down naturally, offering an eco-friendly solution that meets industrial standards and supports waste reduction. Glass and metal provide durable and recyclable packaging solutions, contributing to a circular economy and reducing environmental impact. Explore exciting innovations in plant-based packaging, from seaweed to agricultural waste, offering sustainable and biodegradable solutions. Reusable systems shift packaging philosophy, reducing waste and emissions by encouraging reuse and return, with significant environmental benefits. Flexible packaging innovations include mono-material designs and bio-based films, enhancing sustainability and reducing environmental impact. Edible packaging offers innovative solutions for reducing waste, with technologies like edible films and containers gaining traction. Barrier technologies enhance packaging performance, with innovations like oxygen barriers and bio-based coatings improving sustainability. Nanotechnology offers advanced solutions for packaging, enhancing barrier properties and providing antimicrobial benefits for sustainability. Research and development drive sustainable packaging innovations, from basic research to commercial scale, shaping the future of packaging. Adopting sustainable materials faces challenges like cost, scalability, and infrastructure, but overcoming these barriers is crucial for progress. Balancing sustainability with performance is key, with strategies to reduce environmental impact while maintaining packaging functionality. A practical example of material innovation shows significant carbon and waste reduction, demonstrating the impact of sustainable packaging solutions. Innovative sustainable materials are reshaping the packaging industry, offering competitive advantages and driving continuous improvement. CDG training emphasizes the importance of sustainable packaging leadership, recommending strategies for innovation, compliance, and competitive advantage. Welcome to Chapter 4, where we delve into effective strategies for reducing plastic usage and explore alternative materials. This comprehensive guide is designed to help organizations transition towards sustainable practices in today's global economy. In this chapter, you'll discover core strategies for reducing plastic across supply chains and products. Understanding these strategies is crucial as plastic pollution demands urgent action from all sectors. We'll also provide practical frameworks and real-world examples to guide sustainable packaging decisions. Plastic pollution has severe environmental, social, and economic impacts, necessitating urgent and coordinated global responses. With over 400 million tons of plastic produced annually, less than 10% is recycled, causing significant harm to wildlife, human health, and economies. Plastic packaging contributes to landfill waste, marine pollution, and carbon emissions at every stage of its life cycle. Most plastic packaging is never recovered or recycled, leading to persistent environmental damage across land and sea. Single-use plastics, designed for short product life cycles, create a disproportionate share of global plastic pollution. They have a short lifespan, generate massive waste, face recycling barriers, and are subject to regulatory pressures. Governments and organizations worldwide are implementing bans and reduction targets at an accelerating pace. International cooperation is driving a new era of plastic accountability, with regional targets reflecting varying levels of ambition and readiness. Effective plastic reduction requires a multi-pronged approach, including lightweighting, reuse systems, and material substitution. Each strategy addresses different aspects of the plastic challenge, aiming for the greatest reductions in plastic footprint and compliance outcomes. Reducing material thickness lowers resource use and transportation emissions. Lightweighting is a cost-effective strategy, offering significant material savings, emission cuts, and cost reductions for manufacturers. Reusable systems reduce demand for single-use plastics by designing packaging for multiple use cycles. This approach shifts how packaging is conceived, used, and recovered, emphasizing durability and sustainability. Paper and cardboard alternatives are increasingly used to replace plastic packaging across various sectors. Their familiarity and recyclability make them a popular choice, with adoption driven by regulatory pressure and consumer preference. Bioplastics, derived from renewable sources, offer a drop-in replacement for conventional plastics. While they represent a small but growing share of the market, it's crucial to verify end-of-life conditions before selecting bioplastic solutions. Materials like seaweed, bamboo, and agricultural fibers offer sustainable alternatives to conventional plastics. These innovative materials leverage natural abundance to create functional, low-impact packaging. Compostable and biodegradable materials break down under specific conditions, returning nutrients to the soil. It's important to check certification standards to ensure materials meet environmental requirements. Alternative materials can face cost, durability, and infrastructure limitations that slow their adoption. Understanding these challenges is essential for making informed sustainability decisions. Effective sustainable packaging must balance safety and functionality with reducing plastic This involves ensuring product safety, minimizing environmental impact, and adhering to regulatory compliance. Consumer demand is a powerful driver of sustainable packaging adoption. As awareness grows, purchasing decisions increasingly reflect environmental values, creating market incentives for businesses to act. Plastic reduction improves brand image, compliance, and efficiency. Organizations that lead in sustainable packaging gain competitive advantages, enhancing brand reputation and customer loyalty. A retailer's switch to reusable and paper-based alternatives significantly reduced plastic bag usage. This practical example demonstrates that meaningful change is achievable with clear commitment and strategy. Plastic reduction strategies and sustainable alternatives are essential for reducing environmental impact and supporting circular economy goals. Focus on reducing, replacing, reusing, and recovering materials. Organizations that proactively reduce plastic usage and invest in sustainable alternatives can strengthen compliance, improve sustainability performance, and build long-term customer trust. CDG Training believes this is a strategic opportunity, not just a regulatory obligation. Welcome to Chapter 5, where we delve into recyclable, compostable, and biodegradable packaging systems. These systems play a crucial role in the circular economy by providing sustainable end-of-life solutions for packaging. In this chapter, we explore how recyclable, compostable, and biodegradable packaging systems support waste reduction and circular economy goals. Understanding these systems is essential for sustainable packaging strategy. Recyclable packaging can be collected, processed, and converted into new materials or products. This process reduces the need for raw materials and helps in conserving resources. Recycling reduces waste, conserves resources, and lowers environmental impact. It supports waste reduction, resource conservation, and a lower carbon footprint, all while promoting circular economy principles. Despite its benefits, recycling faces challenges like contamination, limited infrastructure, material complexity, and market volatility, which can hinder its effectiveness and scale. Effective design for recyclability requires collaboration between designers, scientists, and waste management operators to ensure compatibility with existing systems. Compostable packaging breaks down into natural elements under specific conditions. It must meet certain standards for breakdown time, temperature, and residue levels to carry certification. Some compostable materials require industrial facilities, while others can decompose safely in a home compost environment. Checking certification is crucial to avoid contamination. Compostable systems reduce landfill waste and support organic recycling. They enrich soil, provide renewable feedstocks, and support the carbon cycle, returning valuable nutrients to the soil. Biodegradable packaging breaks down naturally through microorganisms. Unlike compostable packaging, it doesn't require specific conditions, but the rate and completeness of breakdown can vary. Not all biodegradable materials are compostable. Understanding the distinction is critical for correct disposal and environmental claims, as they differ in conditions required and timeframes. Sustainable packaging systems use diverse materials like paper, bioplastics, starch blends, and plant fibers, each with unique properties and applications. Recognized standards verify recyclable, compostable, and biodegradable claims, providing assurance to businesses and consumers alike. Certification is not just marketing, it ensures performance. Correct disposal behavior is essential for effective waste management. Awareness, sorting improvement, and reducing contamination are key factors in consumer behavior. Efficient recycling and composting systems require proper infrastructure investment. Collection networks, sorting facilities, processing plants, and end markets are crucial for success. Despite growing momentum, challenges like higher costs, consumer confusion, lack of facilities, and regulatory gaps hinder the widespread adoption of sustainable packaging systems. Businesses play a major role in reducing waste through sustainable packaging systems. From design to supply chain partnerships, they contribute to circular waste management. A food company adopted compostable packaging, reducing landfill waste significantly. This case study highlights the real-world impact of circular packaging systems. Recyclable, compostable, and biodegradable packaging systems are essential for reducing waste and supporting a circular economy. Success depends on design, infrastructure, consumer behavior, and policy. CDG training helps organizations implement sustainable packaging strategies. By reducing environmental impact and improving compliance, they contribute to the circular economy. Explore how sustainable packaging design minimizes environmental impact while enhancing efficiency throughout the product lifecycle. Discover the core themes of sustainable packaging design, focusing on environmental impact, resource efficiency, and the circular economy. Learn about sustainable packaging design principles, including minimizing impact, maintaining function, enabling circularity, and driving value. Understand the importance of eco-efficiency in packaging, highlighting material reduction, emission cuts, and waste decrease. Explore strategies for reducing material usage in packaging without compromising product integrity. Discover lightweight packaging design strategies that reduce transportation costs and emissions. Learn how optimizing packaging dimensions can lead to significant efficiency gains and cost reductions. Designing for recyclability involves ensuring packaging can be easily sorted, separated, and recycled. Mono-material packaging simplifies sorting and enhances recyclability, reducing contamination. Reusable packaging design focuses on durability and efficiency, allowing multiple uses while remaining attractive. Consumer-centric design encourages proper disposal and sustainable behavior through clear communication and intuitive design. Sustainable packaging must balance aesthetics and branding with eco-certification signals. Packaging must protect products while minimizing material use through intelligent design. Digital tools and simulations enhance packaging design efficiency, reducing costs and improving material use. Innovation in packaging design includes bio-based materials, active packaging, smart packaging, and edible packaging. Sustainable packaging design faces challenges like cost management, performance engineering, and consumer education. Life cycle thinking in packaging design considers the entire life cycle from material extraction to end-of-life disposal. A practical example of eco-efficient packaging design shows how sustainability and performance can go hand in hand. Sustainable packaging design and eco-efficiency are crucial for reducing waste, emissions, and resource consumption. CDG training emphasizes reducing environmental impact, improving operational efficiency, and strengthening customer trust through sustainable packaging. Welcome to Chapter 7. Lifecycle Assessment for Packaging Products. This comprehensive guide will help you evaluate the environmental impact of packaging throughout its entire lifecycle, from raw material extraction to end-of-life disposal. Lifecycle assessment is a critical tool for sustainable packaging decision-making. By examining every stage, from raw materials to final disposal, LCA provides the data needed to make smarter, more sustainable choices. LCA is a methodology used to measure environmental impacts associated with a product's lifecycle. It follows a structured four-phase process defined by ISO standards, ensuring consistency and scientific rigor. LCA helps organizations identify environmental hotspots and improvement opportunities across the packaging value chain. It supports compliance, drives improvement, and builds trust with stakeholders. The lifecycle includes raw material extraction, production, transportation, use, and end-of-life disposal. Each stage contributes uniquely to the overall environmental profile, allowing for effective resource allocation. Before data collection, organizations must clearly define objectives, system boundaries, and assessment criteria. This foundation ensures the relevance and reliability of the LCA study. Inventory analysis involves collecting quantitative information on all materials, energy inputs, water consumption, and emissions associated with each lifecycle stage, ensuring data quality and accuracy. Environmental impacts such as carbon emissions, water use, and resource depletion are systematically evaluated and categorized during the life cycle impact assessment phase. Results are analyzed to identify improvement opportunities and generate actionable insights. Interpretation must be consistent with the goal and scope defined at the outset of the study. LCA measures greenhouse gas emissions across the entire packaging lifecycle, providing a comprehensive picture of climate impact from cradle to grave. LCA evaluates resource consumption during packaging production and use, revealing opportunities to reduce water stress and energy intensity across the supply chain. LCA enables a science-based comparison between different materials, moving beyond simplistic assumptions to reveal the full environmental picture. Designers use LCA to optimize packaging sustainability from the earliest stages, embedding environmental thinking into the creative process and improving overall performance. Software tools simplify lifecycle data collection and analysis, making LCA more accessible and faster across organizations of all sizes, enhancing real-time decision-making. LCA supports corporate sustainability goals by embedding lifecycle thinking into decision-making processes, driving smarter environmental decisions at every organizational level. Challenges include data availability, complexity, and methodology differences, all of which must be carefully managed to ensure credible and actionable results. Best practices include accurate data collection, clear boundaries, and regular updates, ensuring that LCA delivers reliable, actionable insights that stand up to scrutiny. A beverage company conducted a comprehensive LCA of their packaging, achieving significant reductions in both carbon emissions and waste generation, demonstrating LCA's practical benefits. Life cycle assessment is the most powerful tool available for understanding and systematically reducing the environmental impact of packaging products, transforming sustainability from aspiration to action. CDG Training believes that LCA is a strategic capability that fundamentally transforms how organizations approach packaging development and sustainability management, leading to long-term business resilience. Dive into an in-depth exploration of how packaging contributes to greenhouse gas emissions and climate change, and discover strategies organizations can adopt to reduce their environmental impact. In this chapter, learn how packaging contributes to greenhouse gas emissions and climate change. Understanding carbon footprint is essential for reducing environmental impact and achieving sustainability goals. Carbon footprint refers to the total greenhouse gas emissions generated throughout a packaging lifecycle. It encompasses every stage from raw material sourcing to final disposal, highlighting the need for targeted strategies to reduce emissions. Emissions are generated during raw material extraction, production, transportation, and disposal. Understanding where emissions originate is the first step toward effective reduction. Extracting raw materials consumes significant energy and generates substantial emissions. Whether for plastics, aluminum, or paper, each process carries a distinct carbon cost. Packaging production processes contribute significantly to carbon emissions through energy consumption, chemical processes, and waste generation, emphasizing the need for efficient practices. Packaging transportation adds emissions through fuel consumption and logistics operations. Every movement carries a carbon cost, making transport mode selection crucial for carbon reduction. Heavier packaging increases transportation emissions and energy use. Lightweighting is one of the most direct and measurable strategies for carbon reduction, offering significant emission savings. Renewable energy reduces emissions associated with packaging manufacturing. The source of energy used in production is a powerful lever for decarbonizing the packaging industry. Different materials have varying carbon impacts across their life cycle. Choosing the right material is foundational in sustainable packaging design. Single-use packaging contributes significantly to global emissions and waste. Designed for one use and immediate disposal, these materials generate disproportionate environmental harm. Recycling reduces demand for virgin materials and lowers emissions. A well-functioning circular economy for packaging materials can deliver substantial climate benefits across the entire value chain. Reusable systems reduce lifecycle emissions through repeated use. By amortizing the production carbon cost across many uses, reusable packaging can achieve dramatically lower per-use emissions. Organizations use carbon accounting and lifecycle assessment methodologies to quantify packaging emissions with scientific rigor and credibility, enabling the identification of high-impact intervention points. Strategies include lightweighting, renewable energy, and sustainable materials. Integrated carbon reduction strategies improve both sustainability and operational efficiency. Challenges include material limitations, cost, and infrastructure constraints. Despite strong motivation to reduce emissions, organizations face a complex landscape of barriers that require strategic navigation. Governments and organizations are introducing carbon reduction targets for packaging industries, creating both compliance obligations and market opportunities for early movers. A consumer goods company redesigned packaging and switched to renewable energy, significantly reducing lifecycle emissions. This real-world case demonstrates the measurable impact of integrated carbon reduction strategies. Reducing packaging carbon footprint is essential for addressing climate change and achieving sustainability goals. Every stage of the packaging lifecycle presents an opportunity to measure, reduce, and ultimately eliminate greenhouse gas emissions. CDG Training believes that organizations that actively measure and reduce packaging-related carbon emissions can improve sustainability performance, meet climate targets, and gain long-term competitive advantages in global markets. Integrating environmental responsibility into every link of the supply chain, from sourcing to delivery, ensures a greener, more efficient future. Learn how sustainable supply chain management and logistics optimization reduce packaging waste, emissions, and operational costs, crucial for sustainable packaging systems. Sustainable supply chain management improves environmental and operational efficiency, from raw material procurement to final delivery, ensuring reduced emissions and waste. Packaging logistics impact emissions, costs, and waste generation. Efficient logistics reduce environmental footprints and operational costs across the supply chain. Transportation contributes to greenhouse gas emissions. Understanding emissions by transport mode is essential for developing effective reduction strategies. Efficient packaging dimensions improve transport efficiency and reduce emissions, leading to space gains, emission reductions, and cost savings. Reducing packaging weight lowers transportation costs and emissions, offering significant benefits across the logistics network. Optimized storage systems improve sustainability by reducing energy consumption, minimizing damage, and ensuring faster, more accurate order fulfillment. Digital systems optimize inventory, routing, and transportation efficiency, transforming supply chains to minimize waste and maximize performance. Organizations should source materials responsibly, ensuring environmental benefits of packaging design are not undermined by harmful extraction or manufacturing processes. Collaboration with suppliers improves transparency and environmental performance across the supply chain, achieving sustainability goals through partnerships. Reverse logistics supports waste, recycling, and circular economy initiatives, creating pathways for packaging to return through the supply chain. Reusable packaging reduces waste and improves resource efficiency, offering long-term environmental and financial returns. Managing risks related to supply disruptions and compliance is crucial for maintaining sustainable packaging operations, protecting both performance and business continuity. Supply chain optimization supports sustainability and carbon reduction goals, making sustainability a strategic business advantage rather than a compliance burden. Understanding infrastructure costs, complexity, and supplier coordination challenges is essential for developing strategies to overcome them and accelerate sustainable transitions. Best practices include route optimization, lightweighting, and digital tracking systems, improving both environmental performance and operational efficiency. A retailer optimized packaging and transportation routes, significantly reducing emissions and costs, demonstrating the tangible impact of sustainable logistics principles. Sustainable supply chains and optimized logistics are essential for reducing environmental impacts and improving efficiency across the product lifecycle. CDG training emphasizes that integrating sustainability into logistics operations can exceed expectations in both environmental and financial performance. Explore a comprehensive guide to understanding how global packaging regulations and extended producer responsibility frameworks shape sustainable packaging practices worldwide. Learn how global packaging regulations and extended producer responsibility frameworks shape sustainable packaging practices. Compliance is crucial for businesses operating across multiple markets and jurisdictions. Packaging regulations play a critical role in reducing waste, improving recycling infrastructure, and promoting sustainability across industries and supply chains. Countries worldwide are implementing stricter packaging and waste management laws, creating a complex but increasingly regulated global environment. Extended producer responsibility is a policy approach that makes producers financially and operationally responsible for managing packaging waste throughout its lifecycle. EPR systems are designed to increase recycling rates, reduce waste generation, encourage sustainable design, and fund waste infrastructure. Governments establish directives and policies to control packaging materials, set waste reduction targets, and define obligations for producers, retailers, and importers. Many countries are banning or restricting single-use plastics, accelerating the transition to alternative materials and reusable systems. Organizations must meet specific recycling and recovery targets established by regulations, with obligations varying by material type, packaging category, and jurisdiction. Accurate labeling helps consumers recycle and dispose of packaging correctly, and is increasingly mandated by regulation across global markets. International standards provide a framework for assessing packaging sustainability, recyclability, and environmental performance, enabling consistent measurement and benchmarking. Organizations must maintain comprehensive records and submit regular compliance reports to regulatory authorities and producer responsibility organizations. Audits are critical for ensuring that packaging systems meet regulatory requirements and that reported data accurately reflects actual packaging volumes and practices. Regulations are reshaping packaging design, influencing material choices, structural formats, labeling requirements, and the overall sustainability profile of packaging systems. International trade requires alignment with multiple regulatory systems, highlighting that proactive compliance improves market access and business resilience. Organizations face challenges in achieving and maintaining packaging compliance across multiple markets, driven by regulatory complexity, cost pressures, and infrastructure limitations. Leading organizations adopt a proactive approach to packaging compliance, integrating best practices across design, operations, reporting, and stakeholder engagement. A packaging company implemented comprehensive EPR programs and achieved significant improvements in recycling rates while meeting all regulatory requirements across multiple markets. Global packaging regulations and EPR systems are transforming packaging design, waste management, and sustainability practices across every industry and market. CDG training highlights that proactive compliance with global packaging regulations and EPR requirements can reduce risks, strengthen sustainability performance, and improve long-term competitiveness. Explore the comprehensive guide to global packaging regulations and extended producer responsibility frameworks, shaping sustainable packaging practices worldwide. Learn how global packaging regulations and EPR frameworks shape sustainable practices. Compliance is crucial for businesses in multiple markets and jurisdictions. Packaging regulations reduce waste, improve recycling, and promote sustainability. They are vital for infrastructure and supply chains, with significant global impact. Countries are implementing stricter packaging laws, creating a complex regulatory environment. Key regions include the EU, US, Asia-Pacific, and emerging markets. EPR is a policy approach making producers financially responsible for the end of life of their products, promoting sustainable packaging practices. EPR systems aim to increase recycling rates, reduce waste, encourage sustainable design, and fund waste infrastructure, supporting a circular economy. Governments set directives to control packaging materials and waste, with targets for recycling and reduction, impacting producers and importers. Countries are banning single-use plastics, accelerating the transition to sustainable materials. This impacts market access and reputation. Organizations must meet recycling targets set by regulations, with obligations varying by material type and jurisdiction, ensuring compliance. Accurate labeling helps consumers recycle correctly, with regulations requiring clear information on recyclability and environmental claims. Standards provide a framework for assessing packaging sustainability, ensuring consistent measurement and benchmarking across markets. Organizations must maintain records and submit reports to regulatory authorities, ensuring accurate compliance with packaging regulations. Audits ensure packaging systems meet regulatory requirements, reflecting actual practices. They are critical for maintaining compliance. Regulations reshape design, influencing material choices and sustainability. They drive innovation in packaging systems. International trade requires alignment with multiple regulatory systems, highlighting the importance of proactive compliance in global markets. Organizations face challenges in maintaining compliance due to regulatory complexity, cost pressures, and infrastructure limitations. Leading organizations adopt systematic approaches to compliance, integrating best practices across design, operations, and stakeholder engagement. A company implemented EPR programs, achieving significant improvements in recycling rates and compliance across markets. Global regulations and EPR systems transform packaging design and sustainability practices, offering competitive advantages. Proactive compliance with global regulations reduces risk and drives sustainability, positioning organizations for future success. Welcome to Chapter 11, where we delve into sustainable packaging labeling, certifications, and claims. This comprehensive guide will help you understand how these elements shape communication and build consumer trust. In this chapter, you'll discover how labeling, certifications, and environmental claims influence sustainable packaging communication and consumer trust. Accurate claims are essential for compliance and credibility, protecting brands from legal risks and building lasting consumer confidence. Packaging labels guide consumers on disposal and recycling, ensuring informed decisions and responsible behavior. They ensure regulatory compliance, build brand credibility, and highlight environmental impact, making them crucial in today's sustainability-conscious market. Sustainable packaging labels include recyclable, compostable, biodegradable, and recycled content indicators. Each type communicates a distinct environmental attribute, aiding consumers and supply chain partners in making informed choices. Recyclability labels guide consumers on proper recycling practices, ensuring materials reach the correct waste stream. They involve material identification, infrastructure checks, preparation instructions, and correct bin placement, reducing contamination rates and improving recycling quality. Compostable and biodegradable claims indicate packaging can break down under certain conditions. However, the distinction between them is crucial for accuracy and consumer understanding, as misleading claims can arise without proper qualifications. Recycled content claims detail the percentage of recycled material used in packaging. Accurate claims must distinguish between post-consumer and post-industrial content, ensuring transparency and consumer preference in sustainability surveys. Environmental certifications verify sustainability and performance, providing independent assurance that packaging meets defined standards. Certifications like FSC, Cradle to Cradle, and TÜV Compostable ensure materials are responsibly sourced and managed. Third-party certification bodies verify compliance with sustainability standards, providing credibility that self-declared claims cannot achieve. They handle application, audit, assessment, and ongoing certification monitoring, ensuring continued compliance. Eco-labels improve consumer confidence and purchasing decisions, creating a direct link between certification and commercial performance. They enhance consumer willingness, premium acceptance, and trust in certification, significantly increasing brand credibility. Greenwashing occurs when organizations make misleading environmental claims, damaging reputation and leading to legal risks. It involves vague terms, false certifications, and irrelevant claims, resulting in significant penalties and loss of consumer trust. Governments regulate packaging claims to prevent misleading communication and ensure genuine sustainability. Regulations like FTC Green Guides, EU Green Claims Directive, and ISO 14021 standard enforce accuracy, verification, and presentation of claims. Organizations must provide evidence supporting sustainability claims, with full traceability across the supply chain becoming a norm. Technologies like blockchain and digital product passports enhance transparency, making it a competitive differentiator. QR codes, NFC tags, and digital product passports enhance consumer information and transparency, enabling brands to communicate sustainability details more effectively than physical labels alone. Authentic sustainability claims strengthen brand value and customer loyalty. Transparent communication is essential for long-term trust, with brands benefiting from a stronger customer lifetime value and improved stakeholder confidence. Sustainable packaging communication faces challenges like consumer confusion, regulatory fragmentation, verification complexity, and rapidly evolving standards. Addressing these requires strategic management and adaptation. Best practices include ensuring accuracy, prioritizing transparency, seeking third-party verification, monitoring regulatory changes, and reviewing claims regularly. These form the foundation of credible and compliant sustainability communication. A case study of a food company achieving compostable packaging certification demonstrates the tangible benefits of credible sustainability claims, including improved customer trust and significant commercial gains. Sustainable packaging labels, certifications, and claims play a critical role in transparency, compliance, and consumer trust. They form the cornerstone of credible sustainability communication in modern markets. CDG training emphasizes that transparent labeling and credible certifications strengthen consumer confidence and reduce legal risks. Organizations that invest in these areas are best positioned to lead in competitive markets. Dive into an in-depth exploration of how consumer behavior, branding strategies, and green marketing shape the future of sustainable packaging. Discover how consumer behavior, branding, and green marketing influence sustainable packaging success. Understanding these dynamics is essential for any organization seeking to lead in sustainable markets. Consumer choices directly influence demand for sustainable packaging solutions. This framework illustrates how consumers move from awareness to advocacy when engaging with sustainable packaging choices. Consumers increasingly prefer environmentally responsible products and packaging. This shift is reshaping entire product categories and supply chains globally, reflecting a fundamental shift in consumer values. Multiple factors shape how consumers evaluate and select packaging. Environmental awareness, convenience, aesthetics, and price all play significant roles in the final purchasing decision. Higher environmental awareness consistently drives stronger preference for sustainable packaging. As consumers become more informed, their purchasing behavior shifts meaningfully toward eco-responsible choices. Visual appeal and functionality significantly affect product attractiveness and overall brand image. Great packaging design communicates quality, values, and trustworthiness at a glance. Sustainable packaging is a powerful branding tool that strengthens brand identity and deepens customer loyalty. Organizations that embed sustainability into their packaging strategy gain a meaningful competitive advantage. Green marketing promotes products based on their environmental benefits and sustainability credentials. It represents a strategic shift from traditional marketing toward values-driven communication. Packaging communicates environmental values through labels, colors, and messaging. Every design element is an opportunity to reinforce a brand's sustainability story and connect with eco-conscious consumers. Eco-labels improve consumer trust and significantly influence purchasing decisions. Recognized certifications serve as powerful third-party endorsements that validate a brand's environmental claims. Transparent sustainability communication builds long-term customer trust. When brands openly share their environmental journey, consumers respond with deeper loyalty and advocacy. Misleading environmental claims can severely damage brand reputation and erode consumer trust. Always ensure that all environmental claims are accurate, verifiable, and supported by credible third-party certifications. Digital platforms provide brands with powerful tools to promote sustainable packaging initiatives, reach eco-conscious audiences, and build communities around shared environmental values. Social media accelerates awareness and demand for sustainable products at an unprecedented scale. Digital influence shapes modern consumer behavior significantly, making social platforms a critical channel for green marketing. Green marketing presents unique challenges that require careful navigation. Balancing transparency, branding effectiveness, and regulatory compliance demands strategic thinking and organizational commitment. Leading organizations follow proven best practices that combine authenticity, transparency, and consumer education to build enduring sustainable brands. A leading consumer goods company redesigned its packaging using recycled materials and launched a comprehensive green marketing campaign. The results demonstrated the powerful business case for authentic sustainable branding. Consumer behavior and green marketing are powerful drivers of sustainable packaging adoption and brand success. Understanding what drives eco-conscious purchasing decisions is the foundation of sustainable packaging strategy. Organizations that combine authentic sustainability practices with effective green marketing can strengthen brand reputation, inspire consumer loyalty, and lead the transition toward responsible consumer markets. Exploring how digital technologies and smart packaging innovations are transforming the future of sustainable packaging systems, enabling smarter, safer, and more sustainable solutions. In this chapter, learn how digital technologies and smart packaging innovations are transforming the future of sustainable packaging systems. Technology is enabling smarter, safer, and more sustainable packaging solutions. The convergence of digital innovation with packaging design is not merely a trend. It represents a fundamental shift in how products are protected, tracked, communicated, and ultimately recovered at end of life. Smart packaging uses digital and interactive technologies to improve functionality, consumer engagement, and sustainability across the product lifecycle. A diverse ecosystem of technologies enables smart packaging capabilities, each serving distinct functions across the supply chain and consumer touchpoints. QR codes have become one of the most accessible and cost-effective smart packaging technologies, providing consumers with instant access to a wealth of product, recycling, and sustainability information through a simple smartphone scan. RFID technology improves inventory management and supply chain transparency by enabling automated, real-time tracking of products from manufacturing through to retail and end-of-life recovery. Embedded sensors represent one of the most powerful advances in smart packaging, enabling real-time monitoring of freshness, temperature, and product conditions throughout the entire supply chain journey. Active packaging goes beyond passive containment by actively interacting with the product and its environment to extend shelf life, maintain quality, and reduce food and product waste. Intelligent packaging systems go a step further than active packaging by communicating product condition and usage information to consumers, retailers, and supply chain operators in real time. Digital printing enables flexible and sustainable packaging production by eliminating the need for traditional printing plates, reducing setup waste, and allowing for short-run, highly customized packaging at competitive costs. Artificial intelligence is revolutionizing packaging across the entire value chain, from design optimization and material selection through to logistics efficiency and end-of-life waste reduction. Blockchain technology enhances transparency and traceability across supply chains by creating an immutable, distributed record of every transaction, movement, and transformation a product and its packaging undergoes from raw material to end consumer. The explosive growth of e-commerce is driving unprecedented demand for durable, digitally connected, and consumer-friendly packaging that can withstand the rigors of direct-to-consumer shipping while delivering a premium unboxing experience. The next generation of packaging innovations promises to fundamentally reimagine what packaging can be, moving beyond containment and protection toward fully integrated, zero-waste, and biologically compatible systems. Digital innovation and sustainability are not competing priorities, they are mutually reinforcing forces that together are shaping the future of the packaging industry. CDG training highlights how technology-driven sustainability will define the next era of packaging excellence. Despite its transformative potential, smart packaging adoption faces significant practical, economic, and behavioral barriers that organizations must strategically address to realize the full benefits of digital packaging innovation. As packaging systems become increasingly connected and data-rich, cybersecurity and consumer data privacy represent critical considerations that organizations must address proactively to maintain trust and regulatory compliance. A leading food company was experiencing significant product waste due to inconsistent cold chain management and consumer confusion about product freshness, resulting in both financial losses and negative environmental impact. Digital technologies and smart packaging innovations are fundamentally transforming sustainability, efficiency, and consumer engagement across the packaging industry. CDG training emphasizes the importance of a data-driven digital transformation strategy to unlock the full potential of smart packaging systems, highlighting opportunities for organizations to enhance supply chain transparency, consumer engagement, and sustainability. Welcome to Chapter 14. Where we delve into packaging waste management, recycling systems, and circular strategies. This comprehensive guide aims to reduce environmental impact and support sustainable packaging goals. In this chapter, discover how effective waste management, recycling systems, and circular economy strategies reduce environmental impact. Understanding these systems is crucial for a sustainable future in packaging. Poor waste management increases pollution and resource depletion. Effective management reduces landfill use and conserves natural resources, highlighting its environmental and economic significance. Packaging waste includes various materials like plastic, paper, and glass. Each requires distinct handling to maximize recovery rates and minimize environmental harm, with plastic and paper being the primary focus. Efficient collection and sorting systems are vital for recycling success. Proper segregation minimizes contamination, ensuring each material type reaches the appropriate recycling stream. Recycling transforms waste into reusable materials, reducing the need for virgin resources. Efficiency has improved globally, thanks to technology and infrastructure investments. Mechanical recycling involves sorting, shredding, washing, and reprocessing materials. It's effective for plastics, metals, and paper, making it a widely used method globally. Chemical recycling converts waste into raw chemical feedstock, handling materials unsuitable for mechanical methods. This technology complements traditional recycling systems. Circular economy strategies focus on reuse, recovery, and regeneration, keeping materials in use longer and extracting maximum value before disposal. Reusable packaging reduces single-use waste and improves resource efficiency. By designing for multiple life cycles, organizations can significantly cut material consumption and waste generation. Extended producer responsibility systems encourage producers to manage packaging waste responsibly, shifting financial and operational burdens from municipalities to producers. Waste-to-energy technologies convert waste into energy, providing a valuable resource. These solutions offer an alternative to traditional disposal methods, enhancing energy recovery efficiency. Global recycling faces challenges like contamination and infrastructure limitations. Addressing these requires coordinated policy, investment, and education efforts worldwide. Consumers play a crucial role in sorting and proper disposal of packaging waste. Education and clear labeling are key to informed participation and effective recycling. Smart technologies like AI-powered sorting and IoT sensors are transforming waste management, improving efficiency and reducing contamination rates. Organizations are adopting circular strategies to reduce waste and improve sustainability. Embedding these principles into packaging design and management is crucial for impactful change. Governments and industries are accelerating circular economy adoption. Regulatory frameworks and market-driven innovation are reshaping packaging systems worldwide. A beverage company implemented circular strategies, achieving significant waste reductions. This real-world example demonstrates the measurable impact of circular packaging strategies. Effective waste management and circular strategies are essential for sustainable packaging. Reducing at source, recycling effectively, and engaging stakeholders are key components. CDG training equips professionals with the knowledge to implement advanced recycling systems and circular strategies, reducing environmental impact and strengthening compliance. Welcome to the final chapter of our Sustainable Packaging Specialist program. Here, we delve into real-world case studies, explore career paths, and discuss certification opportunities to enhance your professional development. In this chapter, we bring together all your learning to explore real-world sustainable packaging strategies. Discover professional roles in sustainable packaging and circular economy management, and prepare for certification to demonstrate your expertise. Organizations implement sustainable packaging through innovation, circular systems, and compliance. This structured approach ensures environmental and business success across the packaging value chain. A global consumer goods company aimed to reduce packaging waste and carbon footprint. They embarked on a sustainable packaging transformation to meet regulatory pressures and consumer expectations. The company conducted a thorough analysis of packaging materials, waste generation, and lifecycle emissions to establish a clear baseline for improvement. The company redesigned packaging using recyclable materials and eco-design principles, focusing on material selection, design optimization, and supplier alignment to enhance sustainability. Reusable and recyclable systems were introduced to reduce waste and close the loop on material flows, significantly reducing virgin material consumption and landfill waste. The company optimized transportation routes and packaging dimensions to reduce emissions, achieving both cost savings and environmental benefits through smarter logistics and right-sized packaging. Consumers were educated about recycling and sustainability through clear, compelling communication. On-pack messaging and digital campaigns encouraged responsible disposal choices. QR codes and digital tracking improved supply chain transparency and consumer interaction, bridging the gap between physical products and sustainability information. The company achieved significant waste reduction, lower emissions, and improved customer trust, showcasing the impact of sustainable packaging redesign and circular systems. Key lessons highlight the importance of innovation, collaboration, and lifecycle thinking in achieving sustainable packaging success, providing a roadmap for other organizations. Challenges include costs, material availability, infrastructure, and regulatory complexity. Understanding these barriers is the first step toward overcoming them effectively. Future trends include circular economy systems, digital technologies, and carbon-neutral solutions. Staying ahead of these trends positions professionals for career advancement. Professionals can work across sectors like manufacturing, retail, consulting, and compliance. The demand for sustainable packaging specialists is rapidly growing. Key skills include packaging design, lifecycle assessment, regulatory compliance, and sustainability strategy. Building a strong competency profile is essential for career success. Certification enhances credibility and opens career opportunities. It signals verified expertise, aiding in career advancement, networking, and salary benefits. Continuous learning and practical experience are essential for success. Gain technical expertise, earn certification, and lead innovation to drive global economy change. Ensure a strong understanding of sustainable materials, circular systems, and regulations before certification. This checklist will guide you in addressing any uncertainties. Practical knowledge and certification are essential for success as a sustainable packaging specialist. Combine theoretical understanding with real-world application to lead change in the packaging industry. CDG Training believes that professionals who combine sustainability expertise with innovative packaging strategies can lead the global transition towards circular economy systems and environmentally responsible business practices. The future belongs to those who understand that packaging is not just a container. It is a powerful lever for environmental transformation, brand differentiation, and systemic change. If you wish to undergo a complete professional course on this subject and earn a recognized certification, visit www.cdgtraining.com and enroll in the Certified Sustainable Packaging Specialist course. You can choose to complete the entire course from the comfort of your home, at your own pace, with no fixed deadlines, allowing you to balance professional development with work and life commitments. Start your certification examination online at your convenience, with results and certification issued digitally upon successful completion. Your entire learning experience, from course access to study materials, online examination, and certificate issuance, is completely online and automated. Learn at your own pace, from anywhere in the world. Appear for the online exam at your convenience, and receive your professional certification digitally upon successful completion. Visit www.cdgtraining.com to enroll, get certified, and take the next big step in your professional journey. You can check the course link in the video description. Take the next step in your professional journey. Earn your Certified Sustainable Packaging Specialist credential and position yourself at the forefront of one of the world's fastest-growing sustainability disciplines. We are proud to have been part of your learning journey. Your commitment to sustainable packaging and circular economy principles will help shape a more responsible and resilient world for future generations. Carry forward your commitment to environmental responsibility in every professional decision you make. Your certified knowledge positions you as a trusted leader in the sustainable packaging profession. Together, certified professionals like you are driving the global transition to a circular economy.